We have seen after the second, we have seen in the world actually 4 industrial revolutions. The first one being the one that started in 1700 and proceeded at the 1800s, where mechanization and the introduction of steam and water power was essential. Then we had Industry 2.0 when mass production was created. Everybody knows what Henry Ford did for car production, for example. And Industry 3.0, which was dominant after the Second World War in 1960s, 70s, and 80s, maybe even in 90s. But nowadays, we are talking about Industry 4.0, where we talk about a smart factory, we talk about autonomous systems and Internet of Things. And in the European Union, they nowadays also talk about Internet of Everything. Everything is connected to Internet, and the knowledge or the intelligence is somewhere in the net. And we talk about machine learning. And in this Industry 4.0, artificial intelligence is very essential. We have also seen a shift from a gadget world where we had different kinds of gadgets like television sets and phones and computers into wearable world in which we have smart watches, smart heart rate monitors, smart shoes, smart this and that. But this has not been the end, because nowadays we talk about nearables, which means that it's related to the European Union, a smart Internet of Everything and smart everything anywhere society, where we have a smart surrounding. And these nearables ensure the availability and delivery of digital services through the nearby smart surrounding. So they provide the required services to the users without using gadgets or wearables. We don't need to wear the gadgets or have them in our hands. Instead, the intelligent and ambient environment offers the necessary and desired services to the users. So the intelligence is hidden somewhere in the environment, but we can use it always, no matter where we are, basically. That's the idea of this gadget-free world and of these nearables. And this is the way the society is going now, and the European Union is putting a lot of research money in reaching that kind of a society. We all know about what cloud computing is. It means that we have data centers and servers somewhere there, not necessarily in our own country. They may be in other parts of the world. And they provide a platform for global accessible services. And what's good in cloud computing is that they are able to provide huge data processing and storage capabilities, which means that they are suitable for the applications with delayed tolerant requirements, because there will be some delays, but you can process a huge amount of data. Then there are some critical applications in healthcare, for example, in smart transportation, in industrial IoT, which require real-time data processing, decision-making with rapid responses in terms of needed services and resources. And for example, when we are in healthcare are monitoring various health-related parameters of a patient in critical condition, longer delays can occur due to the gathering of healthcare data from various sensors and service devices and machines, and then they are sent to the cloud every time for the processing. And therefore, because of this problem, and it's also in manufacturing, it's also in industry in some applications. Therefore, along with the cloud capabilities, solutions which may provide faster responses in the crucial processes are needed. And one answer, first idea was this edge computing. And what does it mean? It means that when we talk about multi-access edge computing and we talk about pure edge computing, it means that it brings some of the computational resources from a centralized cloud near to the edge of the network. An edge can, of course, consist of dedicated routers, base stations, switches, servers, and things like that. This edge computing was introduced by European Telecommunication Standards Institute, ETSI, to ensure the availability of services and resources to the nearest assigned base stations. And it was first, of course, introduced to the radio networks. Edge computing provides some highly important features in the IoT-based environment. For example, you can achieve low latency services. You can achieve scalability. You can achieve an improved privacy. And these are all very important issues in many applications. Scalability is important in industry in many different kinds of applications, for example. So edge networks are considered as the key technology enablers for massive scale in industrial applications. Then after edge computing, there is a new concept which is called fog computing. And this fog computing is considered as a similar concept as the edge computing, which pushes the computation and resources closer to the end devices, closer to the end users. Actually, this fog computing nowadays is considered as a bigger and richer umbrella of resources and services. And an edge can be a smaller subset, a smaller unit of the fog with limited resources. So we can conclude that fog computing has become vital in a number of smart environment-based applications and presents various key features, again, such as low latency, orchestration functionalities, faster data processing, and decision making, which are all important aspects in many applications. And then finally, as funny it may sound, there is a fourth version, and it's called mist computing. Mist computing refers to the data processing and computations at the extreme edge of the network. Now we are at the extreme edge of the network. So in the sensors, actuators, and devices, which are able to do the required limited data pre-processing. Of course, it's limited and it's pre-processing, but it's anyway important. This computing can reduce the network load of access network, which is important, by doing data processing locally and improve the fault tolerance in the systems. So we can conclude that future smart environments will require interrupted delivery of services with rapid data analytics and decision making. Here we have some kind of a ladder scheme of the whole thing. So cloud layer is the upper one, then fog layer in the middle, and then we have edge and mist layer here. It can be also seen in other ways. You can find in literature, if you look at, you can find a little bit varying definitions, but the cloud is the most remote one with large data capabilities. Then we have edge, and we have fog, and we have mist here. And this is the scheme that is relevant now, and systems are designed according to this. Okay, I just wanted to give this short presentation for you about this framework where we are doing digitalization and applying artificial intelligence solutions nowadays. So thank you very much.